Welcome to Hartman Math. Two-part lesson today, beginning with 7.1 linear and nonlinear systems of equations. Beginning, we'll review here with the substitution method, where we're going to solve one of the equations for one of the variables. Then we're going to substitute that back into the other equation. We're going to solve them, and then to get the solution to the other variable, we're going to use back substitution. And you're always able to check solutions to equations or systems of equations by substituting in and evaluating. Example number 1. So we're going to solve one of these equations either for x or y. And whichever one it is, I probably think the second one is the one that we may want to go with. It really wouldn't matter which one. But it probably would be easiest to solve for x if we just add a y to both sides. And now we're going to take that and replace x in the first equation with y plus 5. When we do that, we're going to use parentheses, so y plus 5 squared plus 2y is equal to negative 2. So we need to do y plus 5 times another y plus 5 and do the binomial multiplication. We're going to get y squared plus 10y plus 25. And since it's going to be quadratic, we're going to probably want to get one side equal to 0. At that point, you might want to try factoring here. I do think that it factors. Y plus 3 and y plus 9 as our factors in no particular order. And then we're going to solve, use the zero product property. Solve each of those for y. We're going to get y equals negative 9, y equals negative 3. When we get y equals negative 9, we now need to find the x that belongs to that value of negative 9. And we could go either place here, but might want to go right here. X is equal to the y plus 5, so if y is negative 9, we'll add 5 to that. There's the negative 4. So our solution is an ordered pair. It's a combination of the x and the y. So we're going to use the parentheses in an ordered pair. And then for negative 3 plus 5 is 2. So 2 is the x that goes along with that, and there's our other solution. They are points of intersection on a graph where a parabola and a line are intersecting. Now let's go ahead and try the same problem with the graphing calculator. Go ahead and grab your graphing calculator. I'll grab mine. First thing we're going to do, press y equals to get and access our functions. And then we need to input our equations, our functions, but we need to do it in terms of y equals. So we need to solve each of these for y. So with the first one, if we subtract x squared and then divide the whole thing by 2, in no particular order, I'm going to go parentheses, negative 2 minus x squared, close parentheses, divide by 2. And then for the second one, arrow down, input the second function, y is going to equal x minus 5. And we can go ahead and press graph. As you can see here, pretty good. I think I may want to adjust this a little bit lower to see if I can get a better idea, a better picture of what's going on here. So I'm going to adjust my window. I'm going to press window. Change my Y scale back to 1 where it should have been. And I'm going to go lower on the y, so maybe I don't need to go all the way up to 10. I can change that maybe to 5 and change the y min to negative 15. I'm going to hit graph again, see if I get a little bit better of a picture. So now we're going to use the calculator to calculate the points of intersection. So that's going to be here, calc, so second trace. And we want to find intersections, so I'm going to either arrow down or choose 5. And it says, which one of these curves is your first curve? In this case, it's not going to matter because we only have 2 curves. But you might have 3 curves, and you've got to tell it which 2 you want to see where they intersect. So I'm going to hit enter here to say confirm that is my first curve. It's going to jump down and say, is this my second curve, question mark, sure. And then do I have a guess? Now usually for other things I don't have a guess, but here the guess is going to help it narrow down to which of these points of intersection we're going to find. So I'm going to arrow over to the left and get a little bit closer to here to help it narrow in on that one. So my guess is going to be right there, and it comes up with an intersection point of -4, -9. Remember, it might say -4.000001 or something like that, and we need to be smarter than the calculator, interpret that as the way that it's just making the calculations. It really means -4. Okay, -4, -9. I can repeat the process, do it again, and then on my guess, shift over to this one, and it's going to get that other one. Example number 2, a total of $25,000 is invested in 2 funds, one that pays 7% simple interest and the other that pays 4% simple interest. Yearly interest is given to us. How much is invested at each rate? Let's define our variables. So X is going to be the amount invested at 7%, and Y is going to be the amount that's invested at 4%. Let's write our equations. We have a total amount invested equation. First amount plus second amount equals total amount. Now we can write an interest equation. The amount of interest would be 0.07 times this amount plus 0.04 times this amount is equal to here. Now you're going to see I took that equation and I decimal busted it. I multiplied everything by 100 so that I didn't have to deal with the decimals. Now we're doing the substitution method, so we could take one of our equations. I think the top one's going to be the easiest. Solve for X or Y. So we're going to solve for Y here, subtracting an X on both sides, and then we're going to replace that Y with this quantity. We distribute the 4, combine like terms, subtract 100,000 on both sides. Let's divide by 3, since we've got 3x is equal to 40,500. Dividing both sides by 3, we get x equals 13,500. And then we can use the other equations here to figure out, well, if that's 13,500, what would add up with that to be 25,000? Or just replace the x here, we're going to get the y. Let's make sure we clearly identify our answers, not in terms of an x and a y, which were made up, and say what was invested at 7%, what was invested at 4%. Example number 3, a 3-solution case. We've got our 2 equations, and it already says y equals, so the first step's already done. We already have solved one of the equations for one of the variables, and it's true for both of them, but it doesn't matter. So we're going to replace this y with this quantity. Or another way of looking at it is, since they're both equal to y, set them equal to each other. Now it's a polynomial equation of degree 2 or higher, so we're going to typically want to get that equal to 0. So let's undo, undo, undo. Now we can maybe solve by factoring. Let's start by factoring out a GCF. Greatest common factor is x. And then let's factor this trinomial. So we're going to get x values of 0, -1, and 2. And then remember, we need y values to go with that. So we can go here or here. If you go here, just be careful of the negative as you go through that. If we substitute in a -1, we're going to get -5. If we substitute in a 0, that's an easy one. Gone, 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 we get -1. We're gone, gone, we get -1. And substituting in 2, we're going to get a value of 1. Those are our 3 solutions. checkpoint, go ahead and pause the video here, work through solve by substitution. And you may have done it differently than the way that I'm going to approach it, and that's probably going to be fine as long as we get the same answer. So I took the bottom equation, I solved for x, you might have solved for y, you might have done one of the ones from the top equation. That's fine. And then I replaced that x with this quantity. So I multiplied that by the y, subtracted the 3, multiplied both sides by 2, got it equal to 0, got the negative 3y squared, moved it to the other side so it's positive. It factors nicely. We get y values of 1/3 and 6. And then if we substitute those in, 9 goes with the 1/3, 1/2 goes with the 6. We've got our two solutions. Example number 5, solving a system graphically. So we're going to go back to the graphing calculator here in a moment. We've got x squared plus y squared equals 10. Might know what that looks like. And 2x squared plus y equals -1. We should definitely know what that looks like. And here's kind of our grid ready to go. So when I go to our graph, I'm going to change my window to look like this. All right, let's get the graphing calculator. All right, here's my window. Notice again, based off what I was seeing earlier, that we changed our x min to be -4, x max to be 4, y min to be -4, y max to be 4. So we're looking at kind of like 4 in each direction from the origin. All right, for our y equals, again, we've got to solve for y. So we could have 10 minus the x squared, and then square root the whole thing. So square root of 10 minus x and squared. And before we go on, let's just go ahead and press graph and take a look at what that looks like. So a couple things. Notice there's a little bit of gap here and a little bit of gap here. It doesn't really exist in the true graph. What's happening is, as it comes down, that becomes almost vertical, and the graphing calculator here is unable to show anything that goes completely vertical. So that's why you're kind of seeing a gap that doesn't really exist. The second thing, you might have noticed or thought that x squared plus y squared equals 10 is a circle, and it is. But we're only seeing the top part of the circle. We're only seeing a semicircle. So to get the other half of the circle, remember when we square root, we should really have plus or minus. So that's going to be our y2. We'll input negative, not minus, but negative square root 10 minus x squared. Graph. We had a -1, and we're going to subtract the 2x squared. Graph. So now we're going to go after the point of intersections. So we're going to go second trace to calculate intersections. Now, it's going to say, is this your first curve? And it's not going to be our first curve, because remember, that's this part of the semicircle, and it's not intersecting with the parabola. We do not want that to be our first curve. So I'm going to arrow down to choose a different curve for my first curve. It should jump to right here. And then as our second curve is going to be the parabola. So I'm going to arrow down. And it says, is that my first curve? Yes. So I select enter. Second curve, the parabola. Yes. Hit enter. Do I have a guess? I'm going to arrow to the left to help it choose the one on the left. And it says x equals -1, y equals -3, so we've got the point -1, -3. If we repeat that process to get this one over here, we're going to see that it's +1, -3. Example number 6, break-even analysis. Ivan, the investor, bought a popcorn machine for $629, and it costs $18 per hour to operate, whether he's paying someone, using the electricity, all that kinds of stuff. He charges $45 per hour to rent it out, like school carnivals and other places, birthday parties, whatever. Write the cost and revenue functions for X number of hours rented. So cost, well, there's his fixed cost, and there's his variable cost. We're going to write this in terms of functions. So we're going to use function notation. So C of X, cost as a function of X, is going to equal the variable cost, $18, times the number of hours operated, plus the fixed cost. The revenue function is a little bit easier. He just makes $45 per hour, so R of X would be 45X. So he begins to turn a profit after how many hours? Now we've got to be really careful about how we think about this because, and it's not listed here in the problem, we're going to assume that he only gets to rent it out for a whole number of hours. So if someone says, I want it for 20 minutes, no, you got to rent it out in hour blocks. You can get 1 hour, you can get 5 hours, anything like that. So when we set these equal to each other to see where we're going to break even, and we solve, if it turns out to be something like 5.2, he does not turn a profit at 5 hours. He will at 6 hours. So it's not a simple round off. In this case, it's a round up situation. So we're going to see that basically once he hits 24 hours rented, now we've got a profit. 23 is not. All right, lesson 7.2 is two variable linear systems. It's kind of what we've been doing, but this time really more looking at the elimination method, where we're going to take our system and match up x's or y's, and so that we have same coefficient but opposite signs, something like a 5x and a negative 5x, so that when we add the equations, we're going to eliminate one of the variables. We will then solve for the variable that's left, and then use back substitution once again to find the other variable. So a little word problem situation. 12 liters of a 6% saline solution is obtained by mixing a 4% solution and a 9% solution. How much was used to make the mixture? Good place for us to start with our defining our variables. X is the amount of the 4% solution, and Y is the amount of the 9% solution. So we should have a solution equation because we have 12 liters of solution. Some of that is X, some of that is Y. We also have a amount of salt solution, as a saline solution is talking about a solution where there is salt inside. So the amount of salt is going to create our other equation. In the final part here, 6% of the 12 liters is salt. So 6% of 12 is going to be that right side. The left side, how much salt is in the 4% solution? 4% of X. So it's going to look something like that. That would be the setup. So if we evaluate here, and then again decimal bust, we're going to get 4x plus 9y is equal to 72. X plus y is equal to 12. If I wanted to eliminate x's, I would want to turn this into negative 4x. I could multiply the entire equation by negative 4. Now we add, and here's why it's called the elimination method. X's are eliminated. We get 5y is equal to 24. So y is 4.8 liters. That means there's 7.2 liters of the 4%. So again, don't go back to answering in terms of x's and y's. Be very specific, connected to the problem. All right, checkpoint. Pause the video here. Work through the solutions. If you need a hint, might want to fraction bust these equations, multiply this equation by something so that we eliminate the fractions. Same thing here. Might be a good way to start. If we do that, I would multiply the top one by 10, the bottom one by 6, because those are the LCDs, least common denominators. And then from here, I kind of like the fact that the y's were already opposite signs, so I chose to eliminate the y's, multiply the top one by 5, the bottom one by 6. It does not work out nicely, unfortunately. X is equal to 114 over 37. And substituting that back in, that's how we find the y, x, comma 1. We've got an airplane flying into a headwind. It's traveling 200-mile distance, flying between two cities. It takes 4 hours and 24 minutes to do that. On the return flight, the same distance is traveled in 4 hours. This is kind of a simplistic approach and look at it. We would maybe think in terms of vectors if there was an angle to it, but it's straight into the wind, it's straight behind. So let's define our variables. What is it we're trying to find? Airspeed and speed of the wind. So the A is going to be the plane's airspeed, W would be the wind speed. So as we're traveling into the wind, let's remember that distance is equal to rate times time. We know the distance to be traveled, I'm sorry, I think I said 200, but it's 2,000. Also, into the wind, 2,000 miles, distance equals rate times time. So if we're going into the wind, we've got the airspeed, but the wind is slowing us down by that wind, our speed is going to be A minus W. And the time is given, but we're going to probably just need to convert that into hours entirely there. And then with the wind, now the wind is pushing, helping us go faster, same distance traveled. Now our rate is A plus W in a simple 4 hours of time. From there, I'm going to trust that you could go through and solve that, just kind of looking at the setup. That's it for today. I'll see you next time.